Recording is on.
Yes, I did. Yeah.
All right. So hi everyone. I'm going to talk about the C++ unit testing in online. Um, I don't have a lot of slides. In fact, I only have one. It's the agenda. I'm gonna walk through the design and the code, and hopefully it will all make sense and it will be practical rather than just abstract and theoretical. And we can have Q&A or interaction. I suspect if people ask questions while I'm going through the code, it's going to be easiest, but we'll see how it goes. So first of all, I need to clarify the difference between Cypress and the unit tests, because that is probably the most important thing to orient ourselves as to what we're talking about. Uh, Cypress is more of a client-facing integration style um, end-to-end test versus something that is closer to the actual backend server itself, WSD, and the kit processes, which is what the unit tests are exercising. Unit test as a name is a little bit of a misnomer. It's carried on from the C++ world in general, but these tests uh, are not literally unit tests. They're larger, granular kind of tests that actually simulate interaction with the server on the socket level. So it we do also have unit tests that are specific to classes and functions, etc. That's not what I'm going to cover because that is fairly straightforward. It's standard to pretty much any language. What I'm going to walk through is the infrastructure that we have to um, run scenarios without involving the browser or a user-facing client at all, but by actually simulating interactions with the server that would normally be coming from the user, would be normally coming from the client without having a client. So that's um, what the scope of this talk is. And uh, to do that, what we have is we have an infrastructure where internally we have a fairly shallow hierarchy that starts with something called unit base, and this unit base is the interface for all the hooks that we have. So the idea is that the uh, WSD and Kit code are written in such a way that at certain strategic points where we process messages coming on the wire, on the socket, and we carry on certain activities, we have hooks, which are functions that we call that allow us to change the behavior specifically to test functionality. Um, and the way we do this is, first of all, by defining an interface. And this is what I'm showing here. The unit base is the primary one, and we have specializations for WSD versus the kit, which is less important, but we'll get to it. The idea is that here I want to show you how this works. Is that we have a bunch of virtual functions, and these virtual functions are called at different points in the code, and by default they don't do anything. A specific test that needs to either introspect the incoming data or change the result or the behavior of the logic in general, we'll need to override it and we'll need to do something interesting. in the hope that it would be able to trigger either a specific condition or create the conditions for simulating something interesting that we're trying to test. That's the main idea. And as you can see here, we have events that we're going to see in more detail how we use them. So we have document load event, for example, a view load, which happens whenever a user joins a document. Similarly, we have when the document is modified, unmodified, that's when it is saved, and etc. When saving happens and uploading happens, etc. So all of these are events that we can um, uh, introspect and hook into from a test, and they are called normally from the code whenever unit tests are running. So as an example, let's actually look at document loaded. Document loaded is actually called whenever the loaded message is being sent back. So you can see here that the unit test intercepts the loaded message, and if it is indeed the current message, it will call the on document loaded, which is a virtual function, and a test would need to do something interesting with it. And you can see from my search results that we have a lot of tests that actually do override it, and we will see an example very shortly. Please do stop me if you think that you've lost me, or something is unclear, or maybe you have a question that's going to help you and others. So that's the basic idea. And if we go and look at coolwsd, uh, the main function, we will indeed see that we have these unit WSD and unit base static functions that are being called at various points. Here you can see that we're setting something, we're configuring stuff, etc. And this is where you can realize that how the unit testing is built into the actual code base. Um, I'm going to show you uh, how we detect that we are running a unit test rather than actual production code. This is how we do it. There's a static function, is unit testing, which tells you whether unit tests are effective or not. And later I will show you how that happens at the end of the presentation, because we don't need to worry about that for now. Conceptually, we are aware that unit tests are running, and that's what really matters. Okay, so that's the hooks. How do we actually uh, manage a test? The way we manage a test, there are actually more than one way of doing it, but typically what we do is we create a class, and we typically inherit from the test server. The idea of the test server is that we are simulating um, uh, a storage host. And the reason we do that is because whenever you are testing functionality, you're really testing the end result. In most cases, this is not necessarily true for all the tests, but the vast majority of the tests, we want to test the end result. And the end result typically is manipulating the user data, right? So you're making a change, and you're simulating the user's inputs, and then you're verifying that the changes are indeed saved and uploaded. And then you can simulate all sorts of interesting conditions, like, for example, uploading fails, or it times out, or an error is returned. For example, maybe the user's session has expired, and uploading is now declined with a forbidden response, etc. So um, when you're simulating this kind of a storage interaction, you want to reuse a bunch of code, and that's what the test server is doing. And we can take a quick look at it, but for the time being, that's not really interesting. What is interesting is this particular function that's invoke WSD test. Um, so a quick reminder that WSD is one process, and every document is loaded in a separate process. That's the kit process. So unit testing is different for the kit versus WSD. For WSD, we are testing the main server, and we are sitting between the document, which is the kit process, and the user, which is connected to us through sockets. And that's the vast majority of the tests, because that's really where you can generate and intercept messages from and to the document and the user, and you can modify them, and you can introspect the document's state and output, and uploading and saving, etc. And you can also verify that the user is getting the right messages, for example, if there's an error, and so on. So in most cases, that's where you are in WSD. We do have also coverage for the kits, and I can quickly show you an example. But again, those are the exceptions and not the most common case. So back to how unit tests actually work. It's very simple, and it's really very straightforward. It starts with this invoke WSD test. And indeed, this is the main function that is going to control how your test is being run. The tests are event driven, so keep that in mind. This is very, very important. So it's not a traditional unit test where you have a single test function where you do things in sequence. Rather, you write this test class, and you have this entry point, which is the invoke WSD test, and you have a bunch of callbacks, which are the events like on modify, on document modified, and on document loaded, etc. Right? The way this works is you get called from the polling loop, which is basically the heart of WSD, this invoke WSD test. And you are responsible to track where you have been, what you've done, and what you're expecting to happen next. As an example, when you start the test, if you're supposed to load a document, then you need to remember that you haven't loaded a document yet, and this is what you're expected to do. And you can see here that this phase is what is happening. The phase is tracking what we're supposed to be doing. Right now, we're supposed to be loading a document. Therefore, that is exactly what we do. We log the fact that we're loading a document, we create a socket, and then we run a command. And the macro here is basically helping us do the plumbing, so that um, it would focus on the command itself rather than the mechanism. And the idea is that you are supposed to transition your state so that you remember the next time that you are called, that you don't load again, right? And it is the responsibility of the test author to make sure that there are no edge cases, race conditions, or that kind of bugs in the test code itself. Which, by the way, it's fairly common and easy to have bugs in the tests that make them unreliable and unstable. So one of the things that we do is you always transition the state before you take action, simply because events can be asynchronous. And once you've taken an action like a command, you can get one of the callbacks called. And if you're not in the right phase or state, then you can fail in an invalid and unreliable way, meaning sometimes you fail, sometimes you pass. It all depends on whether the callback is called before you returned or after you returned from executing the command itself. So this is the main idea, and you can see we transition here from the load state to wait load state, and the wait load state basically is waiting for the on document loaded to be called, and when that happens, we do something else. And in this case, after logging and verifying that we are in the right state and we're doing the right thing, we run another command which again simulates a user input, which is a save command. It's a manual save, as if the user clicked save on the UI, and that basically triggers the next thing, which should be that the document should be uploaded, and that's the assert put file. This is what the storage is going to receive, and here we are playing the role of the storage, but with the advantage that we can not just verify that the upload request is correct, but also we can issue user input. So we can simulate edge cases where while the document is being uploaded, because this is basically the storage processing the uploading, we can simulate user input, which is going to trigger a modification while an upload is in progress, right? After this, we should expect that the modified event to fire, and this will tell us that a modification has happened, and we can trigger another save, and so on. And this is basically the structure of a test. This is a very simple test where all we're doing is we're loading a document, modifying a document, and saving a document, and verifying that everything is working fine. You can see here that we have two conditions in the upload. The first one is going to get called the first time when we do the manual save, and the second one is going to get called when in the manual save we do another modification. We expect that there is going to be another upload, and finally, when we have done both conditions, we can mark the test as passed, and this is what this is doing. It is basically ending the test by flagging that the test has passed. And similarly, if we hit a condition that we don't expect, we can either fail an assertion, which is going to log and fail the test, or we can explicitly call fail test, which is going to mark the test as failed, and we'll see what happens in test failure scenarios. I want to pause and see if there are any questions so far. Okay, let's move on. One of the things that we do is to try and minimize the overheads and the time that we have for every test. Since the tests are tied uh, um, with the actual process that is running. So in the case of the WSD tests, WSD process is loading the test, and that means that when the test is done, the WSD process is also it needs to exit to run the next test. This is very costly because initialization and setup is fairly slow. It takes on the order of seconds. So basically, every test would take a few seconds, up to maybe 4 or 5 seconds. But it can be faster. Still, if we want to have not just dozens but hundreds of tests, what we want to do is reuse the process. So a while back, we added support for having multiple tests within a single test module. And the way we do that is basically we can have multiple classes that implement multiple different tests, and we register them uh, all together through this function. So we haven't seen how the registration happens, but again, I'm building towards zooming out and seeing the bigger picture, starting from the functional side, which is what we're interested in, into the infra, so that people are familiar with adding tests themselves that don't exist, not just extending existing ones. But the easiest way of adding a test is to extend an existing one. This particular file has two tests in it, at least two tests that are enabled. There's a third one that isn't enabled, simply because it's a stress test, and we don't want to run stress tests regularly. And the idea is that you pass back an array that includes instances of all the tests or test classes that you have, and the unit test infrastructure is going to execute them one after another, tracking failures and so on. So if the first one failed, it can stop running the subsequent tests and report the failure. Or indeed, I think there is a way to force it to run subsequent tests, assuming that they will be stable. But I think by default, we just stop as soon as we hit the first error. But the idea should be fairly straightforward here. What is happening is we're reusing the same process to run multiple tests. Obviously, we should all realize that there's a huge caveat here, which is if your test needs to have a reliable starting point, then you cannot be running in a multi-test environment. But luckily, these are rare cases where you need a known state. Those would be tests that rely on static instances, for example, the global connection count, or something like that really changes every time that you load a document and add users, etc. So that's how we do multiple tests. And again, every test it should be self-contained. It's a class that has its own, phases and states, and you can have as many um, uh, state tracking bits and pieces as you like, and you coordinate everything, as we've already seen through this invoke WSD test, which is called fairly frequently to tell you do the next thing, and so on. And in many cases, by the way, we don't have a lot of things to do in this invoke function. Typically, we load the document, and the other phases of the test are really checked and triggered and transitioned through the event callbacks. Again, since this is an event based approach, that's the most natural thing to do, and this makes sense because whenever you get a callback for an event, you want to check what you've done and what you were expecting at that point, and not at a different point, right? Because that's the most reliable place to check if your preconditions are satisfied, and to issue the next phase or the next steps based on the logic of your test. Okay. Any questions so far?
Ash, I see comments in the chat.
Sure. You want to read them, or should I
Yes.
go through them?
Maven asking, can we have simulate? Can we have simulate different users for input?
Yes, indeed. I'm going to one of the examples that I have is this fairly complex test, which simulates various failure conditions. And for those cases, we typically have multiple user connections where we simulate um, more than one user interacting basically with our document. Um, One second, let me actually show you an example real quick by okay. Yes, I think the owner termination is a good example, or maybe even the locking is a good example. Um, so here's a case where we have two users. The first we create a socket to initiate the first user's loading. We add a second socket to simulate the second user joining the document. And you can see that in both cases, what we're doing is we're executing the load command, which is what the client is going to do, right? So the client doesn't really know or care whether the document has already been loaded or it is loading it for the first time. But you can see that the socket is different. The socket index is different. So the first one is going to be the one responsible for loading the document, and the second one is going to be the one that joins as a second view, right? And then we can simulate things like disconnecting one of the sockets. So here we disconnect socket 0, which is the actual first user, which is the editor in this case. And we can, by doing that, simulate a case where um, the original user who opened the or loaded the document in edit mode is now disconnected and exited, right? And the second user is the only one connected to the document, and we can verify, for example, that the second user is still able to upload if they have the permission to do so, or maybe we can simulate an edge case where the second user doesn't have write permissions, i.e. the document is read-only for the second user, and in that case, we simulate the expected behavior when the storage rejects, let's say, the upload or the saving of the document. So this would be a good example of doing that. Um, does that answer the question?
Yes.
Very good. And we can have as many users as we like, and we can change the permissions of the users to simulate, a user that previously had editing rights into becoming read-only, and then recovering their permissions and so on. So you can really simulate fairly complex scenarios without having any client, browser side or any client logic except the socket and the commands that are being sent and received on the socket. Okay. Any other questions?
Yeah, there is one question, but I think Kellen already answered. So it's question from Mevin about can we send Uno commands?
Yes, indeed. Uh, and we do that in multiple cases. Whatever we can send from the client side as a command, uh, we can simulate here, right? Because we have the same um, WebSocket that the browser would have or the client in general would have. We have it here. So whatever a client can send down the socket, we can simulate it here. There's no problem. And in fact, if I search for um, Uno something, I'm sure I'm going to find a bunch of unit tests. Here you can see how many unit tests we have that have. I guess pasting is the most obvious one where we have select all, delete, and so on. So yes, we do that fairly frequently as well. Okay. Any other questions?
No.
Okay. What I'm gonna do now is I'm gonna go a little bit deeper into the implementation or the framework that is the unit test. This is only interesting, I guess, from our architectural level, but also for those who want to extend by adding a new test or maybe adding a new hook that doesn't exist. Which is not very common, to be honest, and we should be careful when adding hooks because they make things more complex and potentially fragile. But generally, the way this works is as follows: every test file that we create as a source, as a translation unit, which is a .cpp file, gets compiled into an SO, which is a dynamic library, dynamically loaded library, or a shared object in Unix terms. So ultimately, it becomes an executable in its own right that is loaded into uh, the WSD process, or the Git process, indeed, for the Git tests. So what controls this is the fact that we do need to pass the path to the SO file to the WSD process, so that the WSD process loads the SO, which contains the test logic, and integrates it into its functionality. To do that, we, 1 second, I had it primed, but I lost it. Here it is. It's through calling this initialize or init function, passing it the path to the library. If we look at this, we will see that this is coming from the command line unit lib. And if unit lib is specified on the command line, and I'll show you an example of the command line, we set the path here, and this is the one that is, sorry, this is the one that is passed to the init function. And what the init function does is it DL opens that SO file, and it looks for the exported functions, which really is either the unit create WSD multi, or just unit create WSD for the single test case, which is the fallback, the old scenario. And I think there's one here. Here is one. This is the original um, uh, exported function, which has only one unit test in it. And as I said, that we typically have multiple tests, which is far more efficient than having a single test in every unit. Not least because of the runtime, but also because adding a new translation unit and compiling a new SO for every test is also, it doesn't scale very well in terms of compile time and build complexity and so on. So this approach is usually preferred. So once the unit test SO file is hooked, and we have the callback function, etc. Now we can go through the list of tests available, and you can see there's a fairly complex logic here that initializes everything. We don't have to go through all the details, but ultimately what happens is that we have the get function, the static get function. It returns the instance of the class that we are currently running. So for example, if we're running this test, this class instance is the one that is going to be returned when we call the get, and we can call any function on it. And this is what the actual code is going to do. It's going to call these callback functions or event triggers at strategic points in the life cycle of the process. And by doing that, basically, it is going to invoke the test code if it is there. Obviously, if it isn't there, the default one is going to get called, which does nothing interesting, and the code is going to execute without any tests being run, and that's the scenario that happens in production. So this is how the tests are hooked into the WSD process, and this is how the callbacks are invoked for the different events. When there is no unit test being executed, the get is going to return a dummy instance that really does nothing, and so this will not fail, it will not crash, and it will just do nothing and move on. Um, that's roughly how the tests are integrated, and of course I need to show you the fairly long makefile that we have, where for every translation unit that is a unit test module that compiles into an SO, we have an entry in the makefile under test directory rather, to build them and compile them into SOs. And the order here is the order of execution as well. Um, any questions so far? Okay, so I'm going to show you finally how we deal with failures. This is the output of running the tests, and when there is a test failure, you will get the full command line that was run. And in fact, it's conveniently allowing you to run the test that failed under GDB in case you need to reproduce something under the debugger. But as you can see, these command line arguments are generic. The key one that we're interested in is this last one, which is the dash dash unit lib, as I was saying, and you have the path to the SO, and this is what tells the WSD, the coolwsd process, that it needs to DL open this SO and find all the tests in it and hook them into the test framework so that your test is invoked while the code is running, and you can do something interesting with the WSD process. Other than that, you will see that there is a stack trace that is dumped and a listing of the last commands that were run on the document. This is to give you some sort of a context as to what was happening. And you will also see what assertion failed. In this case, you see that there is a certain assertion check that had failed, and this is why this test had failed. And obviously, you have all the test log output that includes not just your test logs, but also the actual WSD and kit logs as well interleaved, so you can see what was happening and what state you were in and so on. It's worth noting that whenever we are logging from a test, as an example, here test log, or indeed when we are asserting a state or transitioning a state, these get logged with the category of test. So if we search for test, you will see that these log entries are indeed coming from a unit test. They're not entries that are coming from the WSD or the kit process per se. So this helps you find all of the interesting events and activity and assertions that passed and failed from the test fairly quickly by simply either grepping for it or searching for it. And you can see here that um, we had assertions that passed, and this is the assertion code, and it conveniently tells you the value that was evaluated. For example, in this case, we were checking that the iterator plus 1 is equal to the size of a container, and it conveniently tells you that these are not only equal, but their value was 5 at the time. And indeed, when they are not equal, it will also tell you what the value of each was, so that you would be able to more easily troubleshoot and so on, and you wouldn't need to run it under a debugger to introspect or log the values explicitly. It's right there for you. And if we go and look at um, how this code was actually written, we can go to insert delete line 153, and you will see it's fairly straightforward 153. And you will see it's just a simple macro that takes the two sides of the equality equation, and it does the rest for you. It's fairly convenient, I would say. Um, and uh, this is fairly it in terms of how the tests are integrated and so on. When the tests are run, you do get a report that tells you the total number of tests. This is the number of modules, by the way, not the individual test cases that were written within the modules. And you can see in this run, 71 of them passed and 2 of them failed. And again, you will see all the commands for the tests that were run. And if you search for GDB, you will see the command line for the tests that failed. There is also a dump of all the threads and all the back traces, etc., for every failure, so that you can again not have to rerun the tests and under the debugger and hope that you will hit the same conditions in exactly the same way. You already have a lot of information right off the bat that helps you investigate what went wrong. One last thing is, normally we would run make check to execute the unit tests. But recently I've added this, I've reused this check, if you'd forgive the pun, which was created some years ago and wasn't used. And there was a comment that said, do something interesting with this target. And I did just that. I reused it to build and execute only the unit tests without invoking make in the browser and the client side code and the JavaScript and so on, which it saves quite a bit of time. For me, at least, it can save up to a minute. So this only runs the unit tests and nothing else. It doesn't even try to run make in the browser directory or the client code or the linter on JavaScript, etc. So it's much faster. And I think that's it. And I'm more than happy to take questions if I missed anything.
Just one or two points. In some of the tests, there's a way to override the default config settings in the tests. I don't know if you mentioned that already, but there's some places where there's like very big timeouts, and you can change them to be very short timeouts just to get straight to the point. That's kind of handy thing.
That's a very good point. Yeah, indeed. I did miss mentioning them. So indeed, we can change the configuration of WSD to basically create conditions that might be different from the default. In some cases, we need that to simulate something. For example, enabling a feature that's disabled by default. In other cases, we need it to make the testing easier. So, for example, we might reduce a certain timeout so that the test doesn't take minutes; it only takes seconds. And we do use that to great in a number of tests. You can see here how we do it. The hook that needs to be overridden is called configure. This one, you get the configuration object, and you can basically change any values there. And similarly, we can change the check file info that is returned from the storage, again, to create or simulate specific conditions, or indeed to set up the test to our preference. If we look at this configure, by the way, we will see that in some cases we do fairly interesting things with it. Here, for example, we're changing the connection timeout. In other cases, we might do we might change some unusual settings specifically to trigger. Here you can see this is a fairly complex override that is used to test quarantine, the quarantine feature. So we need to enable the quarantine, but we also need to set it up in a specific way so that the test would be able to simulate conditions that we're trying to verify the behavior for.
And then the other thing that came to mind in the past was there's different versions of POCO, and more recent ones are really poor at the speed of logging. So logging by default is an error. So when you showed the command line to reproduce in GDB, the default line is level equal to error or something. So if somebody is debugging it, they might be useful to change that error to something else. And then as an aside, there's this dev note directory, and there's a dependency issue README inside there that describes the various issues with different versions of POCO as to why this one is error rather than info or something more useful.
Yeah, that's a very good point. If I go to the last, sorry. Yes, indeed. The logging level is error by default when you're trying to rerun the command, and the reason for this primarily is because if the error level is trace, which is how we run the tests, so that you get the maximum context and information when the test fails, that would produce not just a lot of log lines, but it would also produce log lines repeatedly, because the poll threads and the various plumbing that happens log at trace level. And unfortunately, if you're in GDB, that output is continuously going to disrupt your interaction with GDB, because it's basically printing on the screen, and GDB's output is going to be moved and lost and so on. So it's really not convenient to have that, and it's only the errors that you want to see in GDB. But obviously you can enable trace, whether because you're running it without GDB, which you can do by basically copy pasting the command without the GDB part, or indeed if you'd like, you can also have trace with GDB, but that is impractical, I feel, because the output is continuously going to replace the GDB output. But yes, this is something to keep in mind, that by default, this command line is slightly different from what is executed. Specifically, the logging level is vastly different. I would hope that we wouldn't have timing bugs that would be triggered simply by changing the log level. That would be really bad and interesting at the same time. So that is not a major concern here. The main concern is basically making it easy for people to use GDB without getting spammed with trace logging. Good comments. Thank you, Kaylin. Anything else? Any other comments, suggestions, or questions? Maybe tips?
I'm not really a tip. It's more like an observation that in case that would be a bit confusing. I think if we have about 2 of these have rewrites or porting of this test framework, so there are at least 3 different styles of the test. And I think what you are mostly demoing is the newest and greatest, and of course that's fine. But we also have this a little bit older version where most of your work is procedural, so it's in a single function, and you invoke a lot of syntax frame and assert response string functions. But at least that's still using this WSD unit thing. And there is the even older one which goes via this unit client. So it's I think the WebSocket task suite is basically a CPP unit task suite, and once that is injected to the WSD code, then we ask CPP unit to run all of these test cases. So that's an even older generation of these things. And I guess over time we intend to port everything to the newer style, but it's the same thing, just in different form, I guess. But perhaps you want to comment on that.
Yeah, that's also a very good point. I intentionally avoided going down that path because I didn't want to confuse people. But I think it's worth mentioning because the code is there and people are invariably going to hit it. So indeed, even though inherently online is event-based and asynchronous, originally, the tests were written in CPP unit style, where there is a single test function, and you do things linearly and sequentially. And obviously, you would ask, how can you do that when it's event driven? Well, the answer is you wait for the event that you care about. So HTTP WS test is a good example. This is a CPP unit class, and you will see that we have, here's one test. This is saving, testing that we do save when we get disconnected. And this is doing something very, very similar, if not virtually identical conceptually. I didn't mean to do that. To the first test that I showed you, which was this one. Um, what this does is it loads the document, modifies the document, and saves the document. Right. That's all it's doing. So it's very, very similar, except it's doing the same thing without executing a manual save. It is doing it through a disconnection, which should also automatically save. And you can see that we have these helper functions that wait for a specific event to happen. So they're basically reading the socket until the event that we are interested in happens. There are multiple problems with this, but there is one huge advantage as well. So first, the problem. The problem is that if you are expecting a certain event, and the order of the events is arbitrary, and you cannot guarantee them, then you will get failures that are simply random because you cannot control for the order of events. And in some cases, the ordering is very important. And that means that you will need to make these helper functions complex over time, because you would need to handle situations where you get X before Y, and you need to handle that differently than getting Y before X. And so the complexity of these helpers grows with the complexity of the tests and the events and the ordering and the meaning of the ordering and so on, which is really, it's just intractable. It's not practical to do that. It's not reasonable to do that. That's the disadvantage. And we would spend a lot of time trying to fix these tests and make them more reliable and more stable, until we realize that this is, it's inherently an event-based process, and we need to do the tests in the same way as well, handle each event separately. And if you care about the ordering, then you can track that by having variables and member variables and whatnot that will tell you if X happened already at the time that you are getting Y, or not. And so you can handle that in the event handler itself, and you can say, I'm getting event Y. Did X already happen? Yes or no? And you can do different things. And that is far more straightforward and far more it's simpler to maintain and extend and so on. So that's the main disadvantage of having these old style tests. The advantage, though, is that things are linear. You can actually see what happens before what. So reading it is more natural. It reads like, do A, do B, do C, verify, D, and then, do these following things. So reading this is easier than reading the event-based tests, which you need to chase the different phases through the phase transitions. So for example, you need to see that here we are in this phase and we are transitioning into this one, and you need to go and look what happens in this phase and so on. So it's, again, there are trade-offs, but ultimately the event-based approach is more sensible, even though it requires a little bit more effort to understand it. It's more reliable and more stable and easier to extend. But you will see these tests. There are quite a bit of them still remaining, although we don't extend them or maintain them. They're fairly reliable, and we just leave them at that. But most of these have already been rewritten in the new style, I expect, and we should maybe do a cleanup job of reducing or removing the ones that are duplicate at this point, just to reduce the number of, the clutter and duplication. All right. Any other thoughts or comments or questions? All right, fantastic. And we are out of time.
Thanks, Ashod. If you guys have any questions or queries, please ask.
Thank you.
Thank you, guys.
Thanks, Ashod.
Thanks, Mevin. Thanks all. We'll see you all next Friday. Happy weekend. Bye-bye.
Bye.
Bye.